For this problem, consider the antiderivative of tangent squared x. If we take a look at the list of antiderivatives, we won't find this one on there. So that's going to mean there'll be some manipulation that lets us get to an answer. So we need to pull out some trig manipulation. For this one, it pays a little bit to know where you're going. So let's start off with the trig identity cosine squared x plus sine squared x is equal to 1. If I want to get tangent squared into the picture, I can divide through this whole entire equation by cosine squared of x. When I do that, I'll get a 1. I'll get sine squared over cosine squared. Sine over cosine is tangent, so I get tangent squared. And then on the other side, I'm going to have 1 divided by cosine squared. 1 over cosine is secant, so we get secant squared on the other side. If I push the 1 to the other side, we get tangent squared equals secant squared x minus 1. Replacing that in my indefinite integral, we notice secant squared is on our list, and we know a rule for how to integrate 1. So the antiderivative of secant squared is tangent x. The way I take the antiderivative of 1 is just to turn it into x. Constant terms go to the constant times x. So my answer is tan x minus x plus my constant of integration.